And so you can use this board if you need to show something and sorry, somehow it should work. Maybe maybe it freezes a little bit.
Or maybe you need to download it and then.
I actually downloaded it, so it's I mean it's local files. So maybe if it's okay for you, then you can.
Yeah, that's good.
Okay, so just 2 minutes. I will share the YouTube link for other participants,
Okay.
and we can start. Yeah, so it works. Ruslan, can you introduce our guest and the topic of today's presentation?
The presentation is about job market sequence of price, and the presenter is Shakespeare from Newton School.
Okay.
Our friend.
Okay, very good. It's a pleasure to be
The
here.
friend of our
That's right, and I'm a friend of this laboratory. I'm very happy to be back here. I presented here last year on network formation, a paper related to Jackson and Molinsky. But today I will kind of talk about a paper that, technically speaking, is not as networky because it's not so involved in graphs. So I'm sorry about that. But it is related to a topic that very much network people are interested in, and it kind of gives you a new perspective on this topic. And the goal, in some sense, at the end would be to combine it with an existing graph framework. Okay. So this paper is on the idea of referrals. So when firms looking to hire new workers, they often ask their existing employees to recommend people that they know from their social networks. And the use of this referral-based hiring is not something that firms do once in a while. There's a clear interest from firm side in hiring through referrals. So this is actually, if I go further down, by the way, this is kind of cool. Every slide is like a reveal. So it's like a little slow rollout for every slide. So Career Builder it's a website in the US. It's actually the leading website in the US, careerbuilder.com, where firms who are wanting to hire new workers, they can post their job vacancies there.
It's some kind of LinkedIn or.
That's right. So it's not necessarily LinkedIn. It's kind of like a place where firms can post vacancies. So if they're looking for jobs, kind of like
Headhunter.
Yeah, similar to that. And according to their internal data, about 70% of firms that hire through this website, they all have referrals-based programs. So majority of firms, they're very much interested in hiring through referrals. So as a result, if you're somebody who's looking for a job, you can find jobs through your social ties, the people that your network, the connections that you have. When it comes to finding jobs through social connections, there's two important aspects. One, these are people that have to be, in your field. So somebody that that can give you a referral based on advice, and of course they have to be employed as well. Sorry.
Something is wrong? It works?
Yeah, it works. So just to give you an example, here's an example of, let's say, a single mother who has, 2 kids, a close friend, and an acquaintance. When you're looking for jobs, obviously she cannot ask her 2 kids because they're not employed, right? So being employed, having connections that are employed in your field is important. So it's not all your connections that we're talking about. We're talking about, your connected people who can give you a referral. But then she has a friend and an acquaintance who are, working in the same field. So she can ask, referral from both friend or close friend or an acquaintance. The question then becomes, which type of connection is more valuable? Is it your strong ties, so your family, close friends, or your weak ties, acquaintances, people that you may know? Although one might think finding jobs to your close friends might be more beneficial, but actually people have found empirically that you can get higher returns from finding jobs through your weaker connections, weak ties. And Granovetter, popularized this idea of strength of weak ties. So he's kind of the father of this literature, who first found empirical evidence for this. But actually, the overall kind of, ever since Granovetter found the strength of weak ties result, the interest in this topic has been around. So, from the early 1970s until now. And at first, people found empirical evidence supporting strength of weak ties, so showing that weak ties are more beneficial for finding jobs. But around the same time, there was equal number of studies showing that strong ties can be beneficial. And actually, there's a nice survey by Topa, 2011, which he kind of collects all the empirical literature on strength of weak or strong ties. And he finds that the overall empirical evidence is kind of mixed. In most recent time, GNL, they used Facebook data, and they found strength of strong ties. But at the same time, Rajkumar and co-authors, they used LinkedIn data, and they found, strength of weak ties. So even now, in the most recent times, it's still kind of, the debate goes back and forth between whether weak or strong ties are beneficial. And the overall empirical evidence here remains to be mixed. So the goal of this paper is to build a model of referrals that can help explain this mixed empirical evidence. And what I do in this paper is that I look at the role of referrals as a signaling device.
Can I ask the question about the initial experiments? Because maybe you read those articles.
Yes.
The power of weak ties. It was the experiments was conducted in some Western countries or not? Because
yes, in Western.
So. Is it actually some differences between different cultures in terms of, for example, Chinese culture is completely different with Western ones.
Yeah.
They are two more hierarchical. They are two more kind of family-based. If you know the good example of Asian culture here is actually Korea and Korean economics. Because the whole Korean economics based on several I forget the word for that, but it's exactly the family in Korea. So Samsung is one family, the Kia was the other family, etc.
Yeah.
So all this empirical result was conducted only in Western environment. Yes.
No. So it's a mixture of like Western, European, and Asian. So actually, if you go back. This takes a bit of time. So for example, if you look at this Wantan Abe and Bian Yakubovich, this is an Asian. So using Asian data, Japanese, Chinese, and these Asian countries. If you look at TOPA, there's a whole collection of data from Europe, from Canada, US, all over the place. So this is quite universal. But the evidence is mixed ultimately. So it's not even in these countries, like one study shows one thing. So if you look at this, like G.Gorbounov, it shows strength of weak ties, right? It's in kind of Japan. And then Watanabe is also in Japan, but it shows strength of strong ties. So the evidence is kind of mixed across the board. And but I think it would be interesting to further look into these cultural differences. So I think that's definitely, I think it's an important consideration. What I'm saying is, I'm not necessarily saying that what you're saying might not be true. I think it's an important consideration. What I'm saying is that empirically speaking, people have not provided clear-cut evidence in either direction, whether it's weak or strong ties, and how this could differ across different countries. So there's this kind of looming mixed evidence, and what I'm trying to understand, using a model, why we may have this mixed evidence. But of course, as we get more empirical data on different cultures and different countries, then I think it would be interesting to understand, given those cultural phenomena, why one might lead to one direction versus another. So technically speaking, what I do is I look at, I don't know how familiar you guys are with signaling models. Usually it's a model of information transmission. There's a sender, there's a receiver. It's very popular in economics literature because a lot of applications are based on this. So in this paper, what I do is I look at referrals. So this is the first paper that's doing this, is looking at referrals as a signaling device. The idea is that there's asymmetric information about abilities of applicants. So let me translate that from economics to math. So basically it means that one side, the person who's recommending has some information about the applicant, and the firm doesn't have this information and wants to get this information using these signals. So the employees, who are signaling can transmit some information to firms by recommending people that they personally know. Much of the literature on signaling is what I would call direct signaling. So my model kind of departs from the standard literature in that what I would call my model is like a model of indirect signaling. So traditionally, there's a famous model of job market signaling by Spence. And in that model, it's like 1970, something there. In that model, there's a worker, he wants to signal his ability to a firm, and he's looking for a job. So he gets the education in order to signal his ability to the firm directly, right? In my model, what happens is that there's a worker who's looking for a job, but he has a friend who's employed at a firm, so then he asks this friend to signal on his behalf his ability to the firm. There's going to be two types of connections. You have the weak ties and strong ties. Weak ties, your acquaintances will only have imperfect information about your ability and characteristics, whereas strong ties will have perfect information about them. By the way, feel free to stop me if I go a bit fast, because sometimes I can speak English rather quickly, so I'll be more than happy to.
What's the intuition behind those terms, direct connections?
The direct and indirect signaling?
Yeah.
Yeah, so the idea is that in a traditional signaling framework, there's a sender and receiver. Sender has some information, he transmits to a receiver. In this framework, there's a middleman, there's an intermediary. So the sender, so there is some, the worker who has his information, there is a sender who's his friend, and then he transmits information to the firm.
But the signal still goes like from one point to another.
That's
direction.
That's true. That's
Okay.
But what happens in the middle? Who knows?
That's always the question. And an important question. Okay, let me just preview the results before I get into the framework. So there are two main results in this framework. First has to do with signaling, so how informative are weak versus strong ties to firms. What I find is that the answer to this question is that weak ties are worse at signaling than strong ties. So what I mean by this is that not only do weak ties have less precise information, they're also worse at transmitting this information to firms. Yeah. The second result has to do with tie selection. So this is kind of the main result of the papers. Do workers prefer weak or strong ties? And I find that the answer to this question depends on the ability of worker. So if your ability is sufficiently low, you will prefer weak ties, and if your ability is sufficiently high, you will prefer strong ties. Actually, in the model, there's going to be ability sort of a continuum variable, and there's going to be a threshold below which workers will prefer weak ties, and above this, workers will.
I'm sorry. I'm sorry.
I know, Reese.
I'm sorry.
It's all good, it's all good. Well, one thing you know is that she's sorry. So that fact has been established.
So she's on the job. So.
Okay. So there's this threshold below which workers prefer weak ties, above which workers prefer strong ties. Now this is the most important result of this paper because it ultimately helps explain the mixed empirical evidence. So how? So you know, as I said, there's this threshold below which workers prefer weak ties, above this workers prefer strong ties. If this threshold is sufficiently low, then on average workers will prefer strong ties. And if this threshold is sufficiently high, then on average workers will prefer weak ties. This threshold is an equilibrium object, so depending on the different parameters of the model, it can be low or high. So then my model can help us uncover some existing conditions which could lead to either strength of weak ties or strength of strong ties.
So what does it mean that workers prefer sometimes some ties over others?
Yeah, they can get higher returns from it. They get higher payoff. So if you're looking for a job, you can find a job to a weak connection or a strong connection. If you prefer weak connections, it means you get a better wage offer or job offer through weak connection or strong.
That means judging based on the result, like they try to find, a worker tried to find a job using both types of ties, and the one that
gives them the best
result is something that is called he prefers it.
That's right. Okay. Then there's also sort of an interesting policy implication of this model. So what I find is that given this result, I find that if you have society with two different groups, one group with lower employment rate and the other group has high employment rate, then what I find is that having more strong ties between these two groups allows firms to get better information from the group with the low employment rate. So this is very interesting result for economists because normally in economics, when we talk about social integration, we're talking about it from perspective of equity. If you have two groups in society and one has a higher employment rate and the other is a sort of a low income neighborhood has low employment rate, you would say social integration could help this group get better employment possibilities. But what my model shows is that this can not only help this low employment group, but can also help firm get better information about the abilities of these workers in this group. So there's not only do you get better equity, but you also get more efficiency in terms of the referrals as a way to transmit information. So usually in economic models, there's this efficiency equity trade-off when you're thinking of policy. But in this particular model, you kind of get both, by having more social integration. So in this particular talk, there's a lot of different details in this model, and I won't have time to realistically go over all of them. So what I will do is I will kind of minimize the signaling aspect a bit, simplify it in a way, so that I can focus on the tie selection, which relates to the main result. And then, if time permits, I'll talk a little bit about the policy. And then, I will kind of do a grand conclusion, bringing it back to Granovetter, who's the grandfather of this referrals literature, and kind of, talk a little bit about what this, given my model, how can we relate back to what he was thinking, and how does it relate to the overall picture. Oh yeah, before I go into my model, let me kind of give you a quick, brief, if you're somebody who's very new to this literature on referrals and strength of weak ties, let me give you a very quick brief on the existing models in the literature. So the literature on employee referrals, we can really split it into two parts. The first part looks at how workers who are searching for new jobs can use their social network to get information about new job vacancies. So Granovetter was actually looking at it from this perspective. Calvo, Armengol, and Jackson have some classic papers in network, which formalizes the network structure and sees how information travels to workers through the network. Then the other side of the literature looks at how firms can use their existing employees to get information about new applicants. So Albert Rees is an economist, a labor economist from Chicago in the 1960s. He actually had this idea, but he was kind of just talking about it in a vague way. And he said that, look, there's two potential reasons for why firms may find it informative to ask their existing employees to recommend people. The first way that he said was that, look, your existing employees, the type of people that they're going to recommend are probably similar in types and characteristics. So this is the idea of homophily, that people tend to be connected with those of similar characteristics. So as a result, there's going to be some positive correlation between the type of your existing employees and the people that they recommend. So based off that alone, firms should be able to extract some useful information from asking recommendations from these employees. So that was his one explanation. So Montgomery 1991 is the model that kind of formalized this idea of homophily and how firms can get information through homophily. The other explanation that Albert Rees had was that, look, your existing employees, they're working for you, so they care about their reputation. They're not just going to recommend to you anybody, right? So they do care about giving you accurate information. So maybe they can communicate proper information to you by writing a nice recommendation letter with a lot of details about what this person does and so on and so forth. So the goal of this paper is to, formalize this idea, the fact that there could be a communication or information transmission between the employee and the firm, and what are the strategic considerations behind this. So this is a very fundamental difference in these two things, is that the first way, based on homophily, doesn't really require any communication between the employee and the firm. I mean, the employee could just recommend and just be completely quiet, right? The firm gets this information automatically because of this positive correlation between the characteristics and types of the employee and his friends because of homophily. But in the other explanation, it actually depends on how employees are going to communicate information and this information transmission stage. So this is what I'm formalizing in this paper. As I mentioned, the literature on referrals is very large. Much of networks literature that economists are working on now started from sociology, and economists tried to make it more mathematical and more precise. So Marston and Gorman has kind of a nice sociology literature on all the referral stuff. And as you mentioned, like the early data on the weak ties and all this, there's a lot of interesting things there. Choba 2011 has like a nice survey on the strength of weak ties and strong ties in the economics side, and also all the different models. By the way, these are the key models in the referral literature. So any other paper that you see with a referral model, it will be some combination of these areas. By the way, how much time do I have? Please let me know. Let's say 5 minutes before.
Sorry, what?
How much time do I have for the presentation?
You have so much time
As needed.
as you need. Yes.
Within reason.
Yes.
We have the whole night then. No, just kidding.
Unfortunately, I can note that the building closed at 11.
Okay.
So.
So I promised something before.
By 8 I would have to go.
Don't worry, you might go much before that. Okay, so here's the plan for the remainder of the talk. I will initially give you kind of the general framework, the key ingredients of this model. Then, I will quickly switch to a uniform quadratic setting. So this is a more simplified version of the model. And the goal here is, not to bore you, but to kind of give you the main insights in the cleanest way possible. So I hope, this version of the model will help in that way. Then with respect to results, I will talk about the equilibrium behavior, so what happens in equilibrium. Then I'll go straight into the application, strength of weak ties, and then I will talk a little bit about the policy and how it relates to granular and the big ideas in the literature. Okay, so in the model, there are 3 kinds of players. Let me just go over here. Oh.
I see the arrows in the lower part of the slides. Maybe use them. Are they working? Can you try?
Like these?
Yeah.
No, they don't work, unfortunately. We tried. Okay, I'm sorry about this. Okay, I think we can read it without the thing. So there are 3 kinds of players. You have workers who are looking for jobs, so JS. means like job seeking workers. You have employees and you have firms. Each worker's type is a pair, theta and capital T. Theta is his like ability or his characteristic. Capital T is the set of connections that he has. Okay. Employees type. There's two types of employees: those with weak connections to some worker and those with strong connection. All firms are just identical. They're just denoted F. So let me just take you to the picture. I think the picture will kind of.
But the connection type is in relation to the job-seeking worker, or
That's right. That's right. That's right. And the information that you have about the worker will depend on your connection type.
And the employees and the firms, are they connected somehow, or you consider them as separate, independent?
That's right. So this is exactly the picture for that. So each ability theta, this ability of workers, beta fraction of them have access to both weak and strong connection, and 1 minus beta fraction of workers only have access to weak connection. So essentially only a fraction, beta fraction of workers have access to both strong and weak connection. Then given an employee, given a worker with connections to both weak and strong, if he has a weak connection employee, then he's connected to a single firm, and if he has a strong, then he's connected to a single firm. All firms are identical. There's a 1-to-1 mapping between each firm and employee essentially.
Can you please share the motivation behind having that we have only weak connection, that we need more to get a strong connection? Why it is not the other way around?
Right. So we're very good. So here, I'm only making the assumption we could have that case, and results wouldn't change. But what I'm giving you is that the main assumption of the model that drives result is that not everybody has access to strong connections. So there is some sort of scarcity with respect to having strong connection. That's the crucial thing. Of course, you can have a scenario where somebody may have access to strong connection but not weak. But the key assumption that you need is that not everybody has access to strong connection.
Does it have any foundation in real life?
Yeah, of course, absolutely. So, people tend to know a lot more acquaintances when you're looking for a job. By the way, people tend to know a lot more acquaintances than, really close friends who are working at a firm. Key thing to remember is that we're talking about connections for referral, right? Of course, you have family members, and everybody has close family members, but it doesn't necessarily mean that they can refer to you at a firm, right? So we're talking when it comes to connections for jobs, people tend to know a lot more acquaintances, people that you met at conferences and small events. But having a really close, connection, maybe your advisor, academic advisor, maybe one. But other than that, it's hard. It takes time to build, right? So people tend to having a strong connection for referral tends to be quite hard.
Also, may I ask you to repeat? Do you have the correlation between the how good the employee is and his ability to have weak and strong connections?
No, we do not. So there's no correlation between that. One could, add it, and as you will see, the results would go in the same direction. It would just strengthen the results. So it's not an assumption we need to add to a certain extent. Okay, now let me tell you about the information transmission aspect. Okay, so so far I've told you about the different players. I've told you about the network and how people are connected between the firms, employees, and workers. Then the third element of the model is information transmission. So each worker, his ability is his private information, but if he has a connection to some employee, then he will also receive some exogenous information about this worker. Now, if it's a strong tie, he will receive precisely what this information is, what this ability is. If it's a weak tie, then he'll receive some imprecise information about the ability of worker. Given this information, then the employee will send a message, a recommendation message to the firm, and then given that recommendation, firm will offer a wage to the worker. Now, the employee, he has his own incentives. So on one hand, he has this reputation cost, so when he's sending this recommendation to the firm, he's not going to give a crazy recommendation. He's going to be somewhat, truthful about what his type is. But at the same time, he also has gratitude benefit from his friend, where he cares about his friend getting a good offer. So the value of gratitude benefit is increasing in the wage offer that his friend gets. So this is kind of the trade-off for the employee, is that the type of recommendation that can get his friend a higher wage offer, or potentially that hurts his reputation. So he has to balance these two effects. So these are the general ingredients of the model. But now we will go into a simplified version of the model, just show you the results. Okay. Yeah, let's go to the uniform quadratic setting. Technology is not always better.
Don't you have a little thing with it?
Yeah, that would have helped a lot, right?
Because obviously your
We can-
slides are designed for that.
Yeah.
If you want, we can. I mean, if it's a problem, what we can try? We can try to firstly again launch the presentation translation from Chrome. Also, I can try to show the presentation through my Zoom and use my computer. If it's okay for you, I can.
No, I think it's fine. In that case,
It's
yeah.
3 additional minutes.
No, it's all good. So that seems more of an operation, a bit larger operation than just sliding through. Okay, so in this more simplified version, it's called uniform quadratic because I'm just going to assume that theta is uniformly distributed between 0 and 1 for simplicity. There's two types of ties, as I mentioned before. You got employees that have weak tie, T weak, and employees that have strong ties, T strong. Capital T here represents, the set of ties that you have. So probability that you have a weak tie is just 1. Everybody has a weak connection. But the probability that you have strong connection is beta. So only a beta fraction of workers have strong connection. And this is the key force that will drive the model. Yeah, so the exogenous information S is about theta that weak and strong ties will receive. If you're a weak tie employee, for simplicity, we will just assume that you receive a useless piece of information. So S is always equal to 0.5, regardless of the ability of the worker. If you're a strong tie, you of course receive the precise information. S is equal to theta. This is the most extreme case. And a lot of the signaling complications get simplified by looking at this special case where weak ties are basically not informative about the ability, and strong ties are fully informed about the ability. The timing of the game is as follows. So each worker chooses a tie that maximizes his wage. So this is the payoff of a job-seeking worker. It depends on the wage that he gets. Wage is a function of rho, which is the recommendation that his friend sends to the firm, and T, which is the type of tie that he has, whether it's weak or strong. So in some sense, when the firm is setting wage, he receives a recommendation from the employee, which is rho. He also knows, whether the first question, if you want to give a referral to a firm at any point in your life, the first thing that anybody that you give a referral to that they will ask you is how long do you know this person. So based on that, they can get a sense of whether it's a weak tie or a strong tie. But a firm has these two pieces of information. Okay. So each worker, chooses the type of offer, whichever offer, whether it's weak or strong tie, that will give him the maximum wage. Each employee chooses recommendation that maximizes his payoff. And remember, employee's payoff depends on this reputation cost. So rho is the recommendation that you send, theta is the ability of the worker, and you get a reputation cost of misreporting. So depending on the distance between rho and theta, you face this misreporting cost. Of course, if your tie is weak, then you may not perfectly know what theta is, so then you have to take an expected cost of this misreporting cost. This is the gratitude benefit that you get from your friends. So it's increasing in the wage offer. That's the most important thing. And gamma kind of represents, how much you value gratitude benefit versus misreporting cost. So the quality of referrals, depends on this gamma right here.
So, I'm sorry, I don't catch. If you have a weak tie, it means that because you don't know the person sufficiently well, you have, as a recommender, you have additional costs for this recommendation, or what?
No, this is for everyone. This cost is like
For any agent in the network.
Anytime. Yeah. Of course, but if your tie is strong, then S is exactly equal to theta. So then you don't have to take the expected cost because the information that you have is perfect, right? So you know exactly S is equal to theta. In that case, this reputation cost is just the quadratic loss function between the recommendation that you send and then the information that you had. Okay? And then, given this recommendation message, then in the third stage, firm will just offer a wage. For simplicity, firm will just offer a wage equal to his valuation of the worker, which is this expected value of the theta, conditional on recommendation rho, and the type of type T. Okay?
What is rho? What is the meaning of it?
Rho is a message, so it's it's like the literal, basically the employee tells him like the ability of this worker is literally rho, equal to rho.
This is the signal
This is the signal.
from who to who?
Employee to firm.
What does it depend on? It depends on the employer? Or,
Yeah, it depends on the employee's preferences, right? So he will send this row, he will choose this row to maximize this payoff function. Okay, very good. With respect to the firm, he will give wage equal to his expected value of the worker, given rho and T. However, the firm, he's fully rational, so he maximizes, and but he has limited information. So imagine if you're a firm and you receive a referral, and the person has a V tie, so this is TV. The firm knows that he has this referral gap providing referral has a V connection with some worker. He knows this. But what he doesn't know is that the guy who's applying for this job, whether he also had access to a strong connection. What the firm knows is that beta fraction of workers have access to both weak and strong ties. And using this information, then he will form rational expectations and operate in that way.
so they know this fraction B. But
That's right. They know this fraction. So they have limited information, right? They only know the distribution of the ties that people can have. So there's 3 stages in this game. You'll solve it, in game 2 you solve, when you have multiple stages, you solve it through backward induction. So first, we will talk about the firm, then we'll talk about employee, and then we will end it with what workers will do. Oh yeah, just a quick, this is gonna be, a quick remark. So I'm not gonna get into the technical details of this. In a lot of signaling models, if anybody has ever worked on this here, there's always multiple equilibrias that can arise. And there's often one needs to use some sort of refinement to refine the set of equilibria. There's some standard techniques here that I'm not gonna go into detail with and bore you today, but if you Google refinements in signaling game, you'll see all of them. So because of these refinements, it allows us to focus on equilibria where recommendations are monotonically increasing. Where recommendations are monotonically increasing in S, and then there's an initial value condition that if you get the lowest value of in S is equal to 0, then you will just give your value, you'll give recommendation equal to your valuation. This comes from the refinement. So in case you're wondering where we got this from, it's a part of the presentation or the paper that I'm not going into details with you in the paper. Okay, so the initial value condition just says that if S is equal to 0, you will just give recommendation equal to your expected value. Okay, now going back to the model, there's 3 stages. First, the worker chooses, which type of employee to ask for a referral from. Then the employee goes, and then the firm. We're doing backward induction, so I start from the firm, then I'll talk about employee, and then I'll talk about the worker. So on the firm side, firm sets wage equal to his valuation of the worker. If the tie is weak, then wage is equal to expected value of theta, conditional on being a weak tie. So sometimes people here make this mistake where they say that, okay, theta is uniformly distributed between 0 and 1. So if the tie is, then the wage should be equal to 0.5. And the answer is no. Because this is going to be an equilibrium object. It depends on, the fraction of workers who are going to select offers from the V tie connection. So this is going to be determined in the equilibrium. Yeah? If the tie is strong, By the way, because it's a weak tie, it doesn't depend on the role, because I'm assuming the connections are not informative. If the tie is strong, then they can potentially be informative. Sorry about this. Then firm's wage offer will depend on whether it can infer its employees' information. So in that case, the employee, now we go to the second stage of the game, the employee has to maximize this function with respect to role. Without going into some of the details here, I'm just gonna take you down to the main result with respect to employees maximization. Okay, based on the maximization problem, essentially what you get is that if the tie is strong, this is the derivative of recommendation with respect to S, okay? It's gonna be equal to this gamma over 2, 1 minus gamma and rho minus S. So it's determined by this differential equation, okay? The employee's recommendation strategy. Now remember, based on the refinement, we also have the initial value condition. So given the initial value condition and this differential equation, it determines the recommendation strategy. Okay, perfect. It didn't go up. So we worked them well. So the equilibrium is then characterized by this initial value condition and this derivative. Now, I kind of want to bring your attention close to the differential equation. Based on the refinement, we know that this derivative should be non-negative, right? Because based on the refinement, recommendation strategy should be monotonically increasing in S. And we know that the gamma is between 0 and 1, so all this is positive. So what the differential equation then tells you is that this rho minus S should also be positive, or non-negative, right? So what that means is that recommendations, will be inflated. The recommendation that you send should be higher than the S, the true value PC.
So I just make it clear, rho 1 means the derivative with respect
That's
to the
right.
first.
That's right. Very good. So just a quick visual of the recommendation strategy. Especially when you're doing a presentation at 6 p.m., you cannot, bore people with equations all the time. Some pictures are helpful, So here, this is the recommendation strategy for the employee. In the horizontal axis, you have S, so the information that you can receive about the ability goes between 0 and 1. So from the initial value condition, we know that if he receives the lowest value, he'll give recommendation equal to that. But any point above that, he will slightly inflate the recommendation. So this is above the 45-degree line. And then at some point, he will hit this highest value of recommendation that he gives. And any point after that, he cannot go any higher, so he will only give recommendation equal to that.
So may I ask you about the initial setup? I asked you some time ago, how does the employee sets his role, the recommendation, the information about the recommendation to the employer? You said that he maximizes some function.
And the differential equation is the solution to that.
Shouldn't it be just the maximum value of the recommendation that maximizes that function? Isn't this logical to recommend, mostly, I recommend this my friend the most, so he will get the higher estimate from the
No. Because you have you also have the misreporting cost. So it's not only that you're trying to maximize the wage offer that your friend gets, you also have to make sure you're not misreporting too much.
There is also that part. Okay.
That's right. And both parts come into play. Okay, so as you can see is that there is a threshold, S star, below which, if firm receives any of these recommendation messages, he can invert back and understand what S was. But once it gets to this point, then there's sort of a signal jamming that happens. For any point above this, the recommendation is the same, so firm won't be able to infer what is the value of S for all these. Whenever the employee says this guy is the best, it could be anything from here to there, Okay, so now this is the crucial point. We're almost there. So if the tie is strong, then firm's wage offer depends on whether it can infer its employees' information. Below this threshold, firm will set wage equal to S because it can. And above that, firm won't be able to infer the employee's information. So I'll give this weighted average of values of S's that are above this threshold. Now wage offer from, okay, let me go. So wage offer from strong tie is, as you can see, is weakly increasing in S. So it's actually strictly increasing in S until this point, and there's like this flat line. Whereas, wage offer from weak ties do not depend on S, right? Because it's always, does not depend on recommendations, so it will not depend on S. So this gives us the insight of how tie selection is going to go. If your ability is theta and you're a worker and you prefer strong tie, getting a job to strong tie, then anybody above you should also prefer strong tie, right? Because it's just going to get higher wage offer. And so this is essentially what leads to the tie selection in the model. So let me give you another graphical view. So this is what the wage offer from strong tie looks like. It's increasing up until S star, and then it's this flat line. Whereas wage offer from weak connection is this flat line. Okay. So what you can see is that it gives you another threshold. If you're if you're a worker whose ability is below this threshold, you get higher returns from using weak connections, right? And then once your ability is sufficiently high, then you get higher returns from using strong connections. So the equilibrium will have this sort of threshold characterization. Let me elaborate on this a bit more. Okay, so equilibrium is characterized with this threshold ability. Everybody below this, will prefer theta star, will prefer weak connections. And anybody above this threshold prefers strong connections. But remember, only beta fraction of workers have strong connections. So beta fraction of them will use strong connections. Which means, 1 minus beta workers above this threshold, they would prefer to use strong connections, but they don't have strong connections, so they have to use weak connections. But this is what precisely incentivizes these guys below to use weak connections, because now, by using weak connections, they can pool up with these higher ability workers and get a higher wage offer, because the firm will kind of put them in one big pool of workers. Okay. So so the main insight of this framework is then that the returns to using a tie depends not only on the tie strength, but also on workers' ability. If your ability is sufficiently low, below this threshold, then you can get higher returns from using weak ties. And once your ability is sufficiently high, then you can get higher returns from using strong ties. Okay? And as you know, in this model, this threshold depends on, it could be, if the threshold is sufficiently low, then on average workers will prefer strong ties. If it's sufficiently high, then on average workers will prefer weak ties, and this is how we can explain the mixed empirical evidence. Okay, so that's the main insight of the model. I will kind of in case you're feeling a bit tired, I think it's almost 7. So now we'll go into a bit of fun part. This granimeter story is very important in network literature. So let me talk a little bit about that. So in the beginning of the lecture, I kind of just gave you a very brief summary of all the different models in network, but let me kind of tell you about the story of granimeter. So there's roughly speaking, there's 2 roles of employee referrals. So one is how they could be used as a way to reduce search frictions. So if you're a worker looking for a job, you can ask your people in your social network about new job vacancies. So granimeter was actually looking at it from this perspective. And his idea of strength of weak ties was this. His idea was that, look, if you're looking for a job, and people that you have strong connections with, like your close friends or family, well, they're hanging around in similar social circles as you. So the type of information that they're going to have about new job vacancies is similar to what you already have, right? So it's not anything new. It's your weak ties that can potentially give you non-redundant, new piece of novel information. Now the problem is that when you take this idea, which sounds really cool, to the empirical world, you find mixed empirical evidence. And this idea sounds very universal. I mean, in some sense, based on this idea, regardless of which industry, which worker is looking for a job, weak ties should always be more beneficial if you're just looking at it from this perspective. And this is, with the mixed empirical evidence on referrals and the fact that it's not always the case that workers find, that workers find it more beneficial to find jobs through weak ties. I created my model because we needed an explanation for why is it the case that workers may prefer to use their strong connection. And the case that I make in this paper is that, look, referrals don't only have the role as a way to reduce search frictions, but they can also be used as a mechanism to screen applicants and reduce asymmetric information. And when you're if you're a firm looking for if you're a firm looking to hire workers, you can use your employees to screen new workers. And this helps us explain this mixed empirical evidence. But actually something surprisingly even more interesting came out from this research is that yes, so this was my initial motivation to help explain this mixed empirical evidence. But what's very interesting is that Granovetter's idea, if you think about it closely, he talks about weak ties as something really good, in the system of referrals. Because weak ties improve the efficiency of how information is transmitted, valuable information is transmitted in the network. But my model shows that essentially, it's actually the low-ability workers that are using weak ties to kind of game the system, right? They're using weak ties as a way. What's very interesting and fundamental is that in my model, there's a lot of low-ability workers who may have access to both weak and strong connections, but they rather use their weak connection because that will allow them to get a better wage offer. So in this sense, weak ties in this way of looking at it is a way for people to hold information from firms and reduce the efficiency of referrals as a mechanism. So this is I think I will end it here. So I think this is kind of the way we turn around the story. Yeah. Very good. Any questions?
So,
I have one question about the first part of the research, about the weak connections.
Mm-hmm.
I remember there was a part where you said that since the company doesn't know a lot about the person who's being recommended from the weak type, it puts the value 0.5.
Yeah.
Where does it put it value?
So that's just a simplified version of the model. That's just for simplification. So this is not a value that the employee puts. This is basically what I'm saying is that the weak connections don't have any information. So the information that they have about the worker, they always know that, they always think that, they always receive the same S, right? Which is equal to 0.5, regardless of what the ability of the worker is. So that's not a strategic decision, that's just, basically saying that the weak connections, if they're completely uninformed about the ability of the worker. Of course, one could relax this assumption and allow for, the case where weak connections may have some information, but less precise information than the strong connection. And the result holds, but it's just not explained. So things get messy.
You showed the graph that it was it showed that the more the employer recommends his job searching worker, the higher we estimate the ability of the job searching worker, right? And that was for the case of weak ties.
For the strong ties.
For the strong ties.
That's right.
Okay, because I was, I thought that this is about weak ties, and I was confused why we forgot about, because I thought that we didn't say any information about the persons and somehow we can estimate.
Yeah.
So
Right. No, so this is the precise, motivation behind this paper is that Granovetter's idea kind of emphasized, why weak ties can be so useful. And in one way in which they may not be so useful is when it comes to giving information. And in that case, strong ties. So in some sense, in this model, I emphasize the importance of and why strong ties can be useful.
I'm far from economic
Yeah.
and from economics, from economic models. How close this to the real world can it be checked that this model have any applications?
Yeah, so in some sense, it kind of goes back to the data, all the mixed empirical evidence on the weak and strong ties. I think in those empirical studies they kind of looked at different industries. In some industries they find the weak ties are more important. In some studies they find the strong ties are more important. So in some sense, this theory, what it suggests is that maybe look at those industries where it's low skilled workers and lower ability workers. And my model would suggest that in those industries, weak connections will be more beneficial if the screening thing is important aspect. But then in environments where high ability workers, there's more high ability work. In those environments, my model would suggest that strong ties should be very important. So one would expect that strong ties would be more dominant in those industries.
I have the last question. What I see is missing is the essential part in nowadays world where you apply for a job. You can apply without having any connection to the company. You don't know anyone from there. Is this not relevant, or this is just the suggestion of the model that we don't see this?
So you could have always applied without knowing anybody in the company. It was just called application process. Now it's just online, so it's a bit faster. But you could always apply. But I think having a friend at the company, even now or before, that's what the model is all about. The fact that if you have a friend at the company, that could be help you get jobs and help you get better jobs potentially.
Okay.
The only experience I have in this area is, of course, the academic job market in the US.
Yes.
Does your model agrees with that?
Yes. So all the mixed empirical evidence really started from the U.S. data. The fact that it was not
specifically academic job.
That's right.
Because it's very special.
In
a sense.
So I think the forces that I have in my model are actually very relevant to academic job market because reputation is an important concern, right? So when you're your advisor writing letters to your students, your reputation is important. So you're not just you're not gonna say all your students are the best.
This is exactly what was happening. I mean, this inflation and value of the referral letters. I mean, they all say it's the next Gauss.
So in my model, this also happens. Remember, there's inflation of recognition.
Okay. Mm-hmm.
So it captures this. So I think in my model, what it says is that strong tie has there's a limitation to how valuable strong ties can be. Precisely the mechanism. And how bad this gets. In my model, it depends on that gamma parameter. How many people care about reputation. Yeah, but you're right. It's getting a bit out of hand.
It is. I mean, it's just pointless to read the letters. They all say the same.
Yeah.
This person is a genius.
Exactly.
I'm curious about possible intersection with real topology of the network because, if I understand correctly, right here, you prove some theoretical stuff about the situation when you actually have some system, but without fixing or taking into account any topological properties.
That's right.
But usually, as far as I remember correctly, for example, what is usually called weak ties and strong ties. The strong ties, it's kind of a tie with a node with whom you have kind of a lot of common friends, for example. Because when we speak about the tie inside one cluster, then this connection is strong just by, by the definition of what is actually a strong connection.
Yeah.
And the weak tie is the tie between two kind of a different parts of the network when you connect it, when you make connections with some kind of different guys from different field, guys from the conference with whom you have a lot of non-common friends. So my question is, did you have some observations or thoughts on is it this effect possibly can affect the mechanisms of network formation? I mean, for example, if I understand that I'm a bad worker, my quality is low, it means that what it means that I should not forming clusters, or what? It means that I should have some friends, but not friend with their friends or something like that. Am I right or not?
So I think, you know, so that's an interesting point. I think assuming that, you know, that weak ties definition is only like unique to the granometer's theoretical perspective. But of course, you know, in the literature of referrals, there's many different ways one could define weak and strong ties. And, you know, even Granometer, when he looked at his empirical study, it's not like he had a data of network, right? He was like, okay, let's see how long they know this person, that's a weak tie, and you know how close they know the person, that's a strong tie. So, you know, empirically speaking, it's definitely, they cannot look, you know, the full network. So they have to use some measure of how long somebody knows someone. But theoretically, I think that's an interesting question. So theoretically speaking, you know, I think what would be very interesting is combining this sort of granometer network idea of this common, you know, friends with, like, you know, information transmission. I think it could be technically very complex, but I think it could be an interesting insight to, you know, tying it back to granometer.
It means that, okay, so just to continue
Yes.
this thought. So, if I can measure my own quality, then forming, having a clusters outside of, having clusters in my ego network can be or beneficial or not beneficial. So it kind of two types of agents in terms of your model. For some agents, it's possibly be beneficial
That's
to
right.
forming a cluster, and in other terms not. Maybe this phenomena can describe the power law in the system, because, for example, you have zero number of efficient agents.
Yeah.
They want to communicate between each other, so we have a rich club. And if you are low quality agent, it means that you should not have too much friends, because if you have too much friends, it means that they know more information about you.
That's right.
Because of strongness of this connection. So maybe it possibly can describe the power law.
That's right. I think that's interesting. So I
In
think
theoretic perspective.
Yeah, that's right. I think how this could affect network formation. And you know, in some sense, my idea, like, you know, initially when I was thinking about these low ability workers using weak ties, I was thinking about actually academia. And in academia, you know, if you're, when you're a student and you're trying to ask for recommendation letters, you want to get a recommendation letter from somebody that will write you a good one, right? Now, if you're a high ability person, of course anybody will write you a good letter because they all know you're high ability. But if you're a low ability worker, you know, and if you took a class of somebody and he failed you, almost failed you, obviously he's not going to write you a great letter. So maybe, you know, meeting people at conferences that don't know you that well, maybe it's the right way. You know, these are the people that can potentially write you a decent letter. So that was kind of the idea that people can gain, you know. And it kind of goes back to you that, you know, if you're a low ability guy and too many people find out about you in terms of network formation, right? So maybe it's not a good idea to network too much, because then somebody will, you know, tell on you that you're.
But if you don't know anybody, then
Then it's also not good.
you,
So you need to
you
know
lose
someone.
anyway, right?
That's right.
Well, also in academia, I do remember it very well. They were saying there would be a group of people who would write not a good letter, regardless, and a group of people who would write a good letter, regardless. And also, it's pointless to write a person who doesn't know you at all, because what this person can say? Well, I don't know this guy. This is my referral.
Right.
So it's not. I mean, maybe it also needs to be taken into account whom you ask. I mean,
Yeah, the person that you ask.
the quality of referral.
That's right.
I mean, you can get a referral from a big name, but I mean, what kind of referral is it going to be? I don't know much about these guys. How helpful it is.
That's right. But I guess the minimal condition is you don't want to ban them. right? So if you're a low ability worker, a low ability person, and all your classes you did terrible, then I feel like asking people that will write bad letters. That's definitely not the way.
But what a good point I think you made is, again, based on my experience. Some people know how to work up the system.
Yes.
And that's exactly what you said, low ability person knowing how to proceed can get a better job of
That's right. So this gaming.
via this weak signal procedure.
That's right, and I think this is the comparative advantage of having a game theory model, right, where people are strategic. So you see how strategic interactions play out in an environment with referrals. So
Yeah.
a lot of existing referral models are very sort of mechanical in their nature, and we don't have the strategic. And so a model with strategic consideration will allow you to have this.
Absolutely. I mean, I was just recently, I asked somebody about the person I knew and didn't think high about him. I said, oh, he's in John Hopkins. Because he knows how to work the system.
Exactly. Absolutely.
Okay, so that's it.
Yeah, that's it.
Thank you for the
Thanks very much.
presentation. I think that I have 0 questions from the online audience. So we can, yes, we can just stop the translation. And